I had wanted to show you some techniques for solving. In this case, we're solving here, and that means we're trying to get x by itself. So notice that the absolute value traps it. So it's really important that we unfold the absolute value. To do that, we have to break it up into a piecewise function, and then we just apply whatever side that we're looking at. So in this case, I have the x plus 3. And with the x plus 3, let's see, I might as well just take care of this whole side all at once. So I'll go ahead and do that all at once, that way there's less confusion. All right, so here's my side work. And what happens here is the absolute value breaks apart into two separate portions. And you can kind of think about it with the absolute value parent function, how it has the normal side, and then it has on the negative side, what would usually go down, it shoots back up. So that's kind of the opposite idea. And so all you do is, when you do these, we have the original one. So the original one is like when everything's greater than 0. That means your x plus 3 is normal. The absolute value goes away, nothing changes. And it's normal whenever this absolute value, whatever's inside of it, is greater than 0. Nothing has changed. So this is where x plus 3 is greater than 0. So nothing has changed on that one. With the other one, and I think we could probably include 0 on this one. There's nothing that changes when x is 0 either. All right, so for the negative side is where things change. So if you can imagine, when this is a -4, the absolute value affects it. If it's anything greater than -4, where it's -3 or higher, then it's going to behave like the absolute value wasn't even there, like it was just a set of parentheses, which is what we have. So when this is smaller than 0, that's the strange one, and that turns into an opposite idea. So we still have that negative sign in front, and then this turns into an opposite, like that. And then we still have the plus 4 at the end. And this is where the inside is negative. So that's an x plus 3 is less than 0. So whenever we have this, we want to simplify it in a way that we can see it a little bit easier. So the top simplifies into, I would just distribute the negative sign. And that's negative x minus 3 plus 4. I'm going to go ahead and solve this also. That's minus 3 to both sides, where x is greater than or equal to the -3. So if x is greater than or equal to -3, everything is kind of normal. And then I'm going to simplify it one more time when I write everything out. So a negative and a negative, those undo themselves, or it's a positive, so everything kind of goes away. And I still have the x plus 3, and I have a plus 4 still at the end. This one, minus 3, solving for that inequality, I get x less than -3. All right, and then lastly, let's simplify it so it's nice and clean. The negative x can't combine with anything. -3 plus 4 is a plus 1. And we still have it where x is greater than or equal to -3. On the bottom here, x plus 7, where x is less than -3. And remember, that's the strange case. All right, so in this original problem, it asked for when x was the smaller of the two, So if I'm just looking at this, when x is the smaller of the two, I'm going to go ahead and just focus on this one down here. And so I'm going to replace that with, or this absolute value gets replaced with that smaller idea. So this is now 1/2. This implies x squared plus 3x minus 2 is equal to, now I'm looking at the smaller one, that's this one, the x plus 7. Okay? So I just got to have that in the back of my head that we're talking about the smaller one on this. If we wanted the other side, we can go ahead and focus on the other side. So now I'll go ahead and solve this. My technique, whenever you have an x squared, it's a polynomial. We're looking for factoring if we can. So we move everything to one side, and we're kind of using the zero product property on this. So I'm going to move everything to one side. I can do it all at once. I'm going to minus x to both sides, and I'm going to I'm going to subtract 7 from both sides. So this side now becomes 1/2 x squared plus 2x minus 9, and that equals 0. All right, so at this stage, it's always easier to have a 1 in front of x squared, and we have some pliability here. We have some flexibility with that 0. So what I'll do is I'll do a clearing fractions idea. So I get rid of the fractions. I multiply by the common denominator, all the fractions go away. So the common denominator is 2. That distributes to each term, and 2 times 1/2 is 1, that's the whole point. And 2 times 2 is our 4x, 2 times 9 is negative 18. And that's what's so nice about that 0, 2 times 0 is 0. Notice now we have something a lot nicer. If this factors, we're looking for two numbers that multiply to be negative 18, that add to be 4. 2 and 9, no combination of 2 and 9 makes 4. 3 and 6, no combination of 3 and 6 make 4. So it does not factor. That means I'm going to go ahead and I need the quadratic formula. So I'll go ahead and clear this side work out. I got the main part out of the way. All right. So this is my ax squared plus bx plus c aspects. C is negative 18, b is 4, and so nice that a is 1. All right. X is equal to, so we're solving for x here. That's what the quadratic formula does when it's equal to 0. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I hope you have the quadratic formula memorized. You need it every once in a while to get through these. And then I just plug in my values here. So x equals negative 4 plus or minus the square root of 4 squared minus 4. A is 1. I'll just put it as a placeholder. Usually I leave it out though as a 1, but it's nice to see it just to make sure we're not making any mistakes. And our C is negative 18. All right, and it's all over 2 times 1. All right, still simplifying here. And we got x equals negative 4 plus or minus the square root of 16 minus, and a minus make a plus. 4 times 18 is 40 plus 32. 40 plus 32 is 72. All over 2. X is equal to negative 4 plus or minus the square root of 88. All over 2. And, oh boy, it looks like we're done. All we have to do is calculate this. I could simplify if I wanted to, but we wanted decimal answers for this original problem. So I'll just go ahead and plug it into the old calculator. Swoosh. All right. Equals. So we got two answers here. The negative 4 plus square root of 88 over 2, and the negative 44 minus square root of 88 all over 2. Just be careful how you type it in. I like to kind of deal with each of these in the order of operations. So I would say negative 4 plus square root of 88 equals that answer divided by 2. It's equal to. And I want it as a decimal. Oh, I got 2.6904 ... That's that one. And on the other one here, I get let's see, the negative, I put 44. Oh boy, that would have messed it up pretty good. All right, -4. Let's see, -4 minus square root of 88 equals divided by 2. And this is negative 6.6904 ... Now, this one, the one that's on the negative side, so we kind of use the graph to see which one's which, but of course we can see that this one right here is your final answer. And I think it said it wanted the answer within 0.5 decimal places. So you'd be okay with 0.5 decimal places. So if you added 0.5 here, that would be a 7.1 to basically a 6.6 on the negative. Okay. So the point though that I kind of wanted to kind of get into was using a piecewise function to attack the absolute value function.